Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class we have already completed the Newton's three laws of motion, first law, second law and third law. We have some detailed discussions on those laws, some applications, mathematical derivations. If you have not watched those videos, please do watch those videos in order to have a clear concept on those topics. Okay, today we are going to talk about another law of Newton, which is called the Newton's law of gravitation, and it is related to the mass of an object. Okay, so without wasting much time, let us quickly move into our topic. So make down the heading Newton's law of gravitation. Okay, so what is actually Newton's law of gravitation? So let us understand it in details. Okay, in order to understand Newton's law of gravitation, you must be aware of the fact that every matter has a property called mass. Okay, so you must be knowing that each and every matter has a certain mass. Okay, and mass is basically nothing but the amount of substance, amount of matter that a substance, that a object carries. It is the mass. Now, what does the Newton's law of gravitation says about? Now, this is a very interesting fact. We may not be able to realize this all the time, but it is actually happening or actually taking place. Okay, so what is the fact? See, Newton stated that every object in the universe, each and every object in the universe, be it a large object, be it a small object, whatever be the object, it has certain mass, and due to this property of mass, each and every object tends to attract other objects. This is the simple statement of Newton's law of gravitation. Okay, so what you can write? Newton stated that. What he stated? He stated that every object in the universe attracts other objects. Okay, so Newton basically stated that every object in the universe attracts other object. This is a very basic fact. Okay, now actually and this property of attracting other object is due to the mass of an object. So why does this property of attracting comes? This is due to mass of an object. As you know, every matter has certain amount of mass, so obviously due to that mass the property of attraction comes into play. Okay, fine. Now question might be coming in your mind, what is the value of the force that is working when two bodies are attracting each other? So Newton did some experimental activities and came to the conclusion. 2 points he mentioned. What are the 2 points? He said that, okay, so if you have noted this point, I am going to use it. If not, please pause the video and note down the point. It's very important to write when you are watching the video simultaneously, because writing makes your study better. Okay, so it is important to write everything that you are seeing in the video side by side, so that it makes a better understanding. Now Newton said that if there are two objects, okay, if there are two objects, say this is an object of having certain mass m1 and it is at a certain distance from another mass m2, and this distance is basically r. Okay, so this distance is basically r. Now what happens? But this Newton stated that when basically these two objects are placed at such distance, and m1 and m2 are basically considered to be as point masses. This is a very important point. They are considered to be point masses. Okay. So it can be also applied to larger objects also. So each and every mass has this property. Okay. So here I am considering two masses. So Newton said that some force will act between these two bodies. The mass m2 will be attracted by the mass m1 with a certain force, and that same force, mass m2, will also attract mass m1. So please note it down that m1 attracts m2 with a certain force, okay, and that same amount of or same force is being exerted by m2 on m1. So with a certain force, and m2 also attracts m1 with the same force. Okay, remember this very important point. The force acting between them tends to be the same, not different. Thus the directions are opposite. If m1 is attracting the mass m2, it will be from right to left, whereas m2 is attracting the mass m1, it will be from left to right. Okay, fine. Now Newton experimentally found that if the force acting between these two objects is F, then that force is directly proportional to the product of the masses. So this is the first point, you must note it, that the force acting between the two objects of mass m1 and m2 is directly proportional to the product of their masses. Second point is that this force is also inversely proportional to the square of the distance between the two masses. So A proportional to 1 by r square. And basically this kind of relation is called the inverse square law. This kind of relation is called the inverse square law. Okay, so this kind of relation is called the inverse square law. Okay, so inverse square law. So inverse square law is that law which states that with increasing distance, basically the force or the certain parameter, here it is force, will decrease as square of the distance. Okay, so this is the inverse square law. Fine. Now if you combine these two laws, what does the mathematical equation stands out to be, or the mathematical formula? So F will be then proportional to m1 m2 by r square. Definitely you can write it like this, m1 m2 by r square. Fine. Now this is not an equation, this is basically the proportionality relationship. Now if you actually can find out the mathematical equation, you need to apply a constant quantity. Okay, so if we want to convert this proportionality relationship into an equation, what we have to do, we have to multiply this by a constant. Okay, so what is the constant that we have to multiply, that we multiply, and these are determined by some experimental activities. Okay, so that constant is basically nothing but called the universal gravitational constant, or capital G. So after this I think you have noted down. Okay, so what will be the equation looking like? It will be looking like something like this. It's F is equals to capital G m1 m2 by r square. So this F, or this G is called the universal gravitational constant. This is called universal gravitational constant. Okay, universal gravitational constant. Fine. And what is the value of this universal gravitational constant? It has a value something of the order 10 to the power minus 11, and if you consider the exact value, it turns out to be something like this: 6.67 into 10 to the power minus 11. Now if you consider what is the unit for the G, it is something like this. If we write the equation for G, then it turns out to be G equals to F into R square divided by M1 M2. Okay, so this will be, the unit will be Newton meter square, then kg to the power minus 2. This is the unit of the universal gravitational constant. Okay, 6.67 into 10 to the minus 11 Newton meter square kg to the power minus 2. Okay, so this is the Newton's law of gravitation. Okay, now this gravitational force that is acting between the two objects. Okay, so this is basically dependent on the mass as well as the distance between the two masses, and this force is variable. If the masses move closer, the force of attraction increases. If the masses move further away from each other, then the force of gravitation decreases. Okay, and if we want to define the gravitational constant G, how can we define that? Okay, how can we define that? So we can easily write from this equation that capital G is equal to what? F into R square by M1 M2. So you can define universal gravitational constant like this, that it is equal to the force of attraction between two masses of unit or 1 kg. Okay, so you can define this as universal gravitational constant can be defined as the force of attraction working between unit masses, when they are kept at unit distance. Okay, so if you consider SI units, then if the masses are considered or taken to be as 1 kg, both the masses are taken to be as 1 kg. So if M1 is equal to M2 is equal to 1 kg, as well as the R is equals to 1 meter. So two masses of 1 kg kept at a distance of 1 meter apart, then the force of attraction acting between these two objects will be numerically equal to the universal gravitational constant. Under this condition, the capital G will be having a value of F. Okay, so this is how you can define the universal gravitational constant. Okay, so with that we come to the end of this lecture. We will be having more discussions on this topic. Okay, we will be doing that in the next class. Till then, please do study well. If you have any query, mention it in the comment box. We will be happy to solve your problem. Thank you. Goodbye.